Hi guys. My name is John Kilu. I'm a junior at Deerfield Academy, and my presentation is an AI-powered mobile application for reducing food waste through cost estimation and user awareness. So, problem: the food waste in America. So currently, 9.2% of the global population lives in extreme poverty, and in the US alone, 37.9 million people live in poverty, and an even greater number of Americans go to bed hungry. 54 million people in the United States battle hunger, including 1 in 5 children. One might think that there is not enough food being produced to feed the population. However, the opposite is true. The US is one of the largest agricultural producers in the world. However, every year, the US wastes 133 billion pounds of food, totaling to 40% of its agricultural output, and over the global average. In fact, the average American wastes up to a pound of food per day, with dramatic increases in the holiday season. If food waste could be reduced, more people would be fed, drastically reducing the current food crisis that America is grappling with. The environmental and economic impacts of food waste is just as significant as the social. The EPA estimates that 170 million metric tons of carbon dioxide emissions are generated because of food waste, the same amount generated by 42 coal-fired power plants per year. On top of this, the US annually loses almost $500 billion from waste, a huge economic loss that is felt from the most upon the classes already struggling with rising living prices. Food waste accumulated at every stage of production, from processing to distribution to consumption. Reducing this will not only help our people, but the environment and our economy. Now, existing solutions. So our project improves on these methodologies drawn by offering a user-friendly, data-driven app that combines image recognition and cost tracking to empower individuals in reducing food waste. My solution. Amidst the rapidly changing environment fostering the growth of artificial intelligence, we advance a software readily accessible to users through both iOS and Android that utilizes Google Gemini to estimate the monetary value of food that users waste. This service allows users to input photos of cafeteria trays or plates that can contain their leftovers, and using estimates from Google Gemini will provide the total cost and sub-cost of the components of food that they or others are wasting. One can use this software to track food waste in cafeterias or restaurants over time, gathering invaluable data that they can share with the directors of culinary services on how they can better allocate their resources and mitigate waste. Now, compared to recent efforts by cafeterias that seek to lessen food waste by removing trays, using smaller plates, or generating smaller meal sizes, their attempts all have glaring flaws, being that some of them have high transition costs, while others might leave students feeling hungry after meals. Also, their efforts might not be backed by data, meaning that they may be cutting food production down in all the wrong places. Meanwhile, our service provides raw, meaningful data that identifies and then addresses the most prevalent problems um, that dining hall should then pour their efforts into fixing, of which they can also expect to see the greatest results. Our app Foodnomics is readily accessible to people on both iOS and Android, being a solution that starts with the people eating the food themselves instead of a higher management team uh, associated with larger corporations. This will bring more awareness to the problem of food waste and empower people to start wasting less, as they can see results immediately on the app, with lower cost of food waste meal by meal. Now, our demo of the app. Food waste. Next, I'll show you how the app works. Here, we have our home screen. Next, we have our food waste section. Users can take a photo of leftover food using their camera. Here, I'll use a photo from the gallery. Next, I'll press Analyze, and it'll show the cost of individual food components, as well as the total food cost. Here's also an option to adjust prices, accounting for regional differences in food cost or inflation. Now I can go to the history page. Here, you can see total cost, as well as sub-cost of individual components. This way, cafeteria managers can identify items wasted the most and concentrate their efforts to maximize efficiency. Here is the daily breakdown. so a user can track their progress to minimize waste. With Foodnomics, we can track and analyze food waste and figure out ways to reduce waste and fight hunger. Thank you so much. Perfect. So that's a brief demo of how the app works, and how users can directly generate raw valuable data to help them on their food wasting efforts. So our experiments now. So a potential blind spot in our program we recognize is the accuracy of artificial intelligence models in detecting and classifying food components. Ensuring accuracy is vital in providing reliable cost estimations and food waste statistics. To test the AI model's accuracy, we will create a smaller dataset of labeled images, using 100 images split evenly across well-known items such as bread and rice, and less common food items such as tofu. The model's classifications will be compared against these labeled images, measuring precision and recall metrics. This controlled experiment allows for focused evaluation without requiring a large dataset. Images for the test will be sourced from the USDA Food Image Database, ensuring consistency and relevance to common food items. By analyzing the results, we can pinpoint areas for improvement in the model's classification accuracy. And our experiment revealed a mean precision of 87% and a recall of 84% across 100 test items. Well-known items such as bread and rice showed a high precision rate of 92%, while less common items like tofu were less accurate, with a 78% precision. The median precision was 85%, and the lowest accuracy was observed in the less represented items. The results indicate that while the model performs reliably with familiar food, it needs improvement in recognizing less common items. Expanding the dataset with additional images of unrepresented food items could enhance the model's robustness. And the better than expected performance with certain less common items, such as quinoa, suggests that distinct visual characteristics can aid classification, though a large, more varied dataset will be essential for further improving classification accuracy for our AI model. Another blind spot is the accuracy of cost estimation based on regional food prices. Ensuring accurate price calculations is essential for users to trust the app's final insights. To test the accuracy of cost estimation, we will compare the AI-generated costs of 50 food items against actual market prices from two distinct regions. The test dataset will include both staple goods, such as rice and bread, and region-specific items, such as tofu in urban versus rural markets. The experiment will calculate the mean difference between AI-estimated and actual prices. Controlled data will be sourced from the USDA and local grocery store data to ensure accuracy. This will help evaluate the model's effectiveness in estimating costs across different regions and identifying discrepancies. Our experiment showed a mean cost deviation of 5% for staple foods and 12% for region-specific items. The median deviation across all items was 7%. Staple items like bread and rice exhibited lower deviations with less than 3% difference in both regions, demonstrating the model's high accuracy for common staple food items. However, region-specific items like tofu displayed a larger deviation, up to 15%, due to regional price variability. The findings highlight the need for users to input local price adjustments for improved accuracy. And these results confirm that while the model is effective for generalized costs, incorporating a reliability, particularly for regionally diverse items. And this experiment underscores the importance of adapting the app's cost estimation logic to cater to varying market conditions. Um, Now our conclusion. So while our project demonstrates significant potential in reducing food waste, several limitations remain. One notable challenge is the reliance on image recognition technology, which may struggle with inconsistent lighting or ambiguous food presentations, leading to occasional misclassifications. Additionally, the app's cost estimation accuracy can be affected by regional price variations, which may limit its effectiveness without user input for adjustments. The model's performance is less common or culturally specific food items is another area of improvement, as it relies heavily on the diversity of our dataset training the AI model. Now, further improvements could include expanding the training dataset to encompass a wider variety of food items and conditions, integrating dynamic pricing models based on real-time market data, and enhancing the app's user interface to provide for more intuitive guidance. Additionally, incorporating machine learning feedback loops from user corrections would improve accuracy over time, making that more reliable and effective for a broader audience. Now, in conclusion, our app Foodnomics offers a practical, artificial intelligence-driven solution to combat food waste by providing users with actionable insights into their consumption habits. By leveraging technology to promote behavioral change, the project highlights the critical role of individuals in reducing food waste in society, fostering sustainability, and contributing to global efforts to address food insecurity. I'm John Liu. Thank you so much for listening.